week. I'm going to go and delete that. So inheritance is a way of making any class structure efficient. I'll show you a bunch of examples. So let's start with something basic. So the inheritance comes from extending one of the classes. So let's say you have a class. So use the class that we actually haven't used. Let's start with something we have used. So let's say account, right? So bank account. So let's say you have an account class, and then after that you have two other classes below that, right? So one could be checking. One could be both account class. But if you have declared them this way, this is called inheritance. So what happens is, and also there's a class above account, which is, it only goes one way, but this is the object class, right? So this is object. So object is built-in class. I think we went over that last week, that all the classes you're going to be creating, comes from object class. So now what happens is this become is a parent class, and this account is a parent class for an account class, checking, and then saving account coming from the account class. So now this is the parent, this is also a parent. So this is also a parent class, and now these two classes, this one and this one, they become child classes. So inheritance is inheriting everything from your parent. That's what inheritance exactly means. So if you have a parent class, you're inheriting all the functionality from your parent class. So now, if you're designing a class structure, something like this, what you're going to be doing is you're going to be taking what's common in both of these two. Whatever is common, let's say account number, one of the fields, name of the account, all that, you would put it all that stuff in the account. You wouldn't put it inside of any of these accounts in these things. Now, what you're going to be doing is you're going to be inheriting all that stuff in here and then all that stuff in here. So what's going to be happening is all the common functionality, let's say the fields, and the fields are name, number, account number, anything that's common between checking account or saving account, that would go into account. Now, when you're inheriting all that stuff, all this stuff would be copied into checking account and saving account. So all that stuff is in one place. You can add more functionality to it, obviously. Let's say deposit functions, all this, when you add it, you would add it in account, and then you'll be inheriting that into checking account and saving account. So that way you don't have to write it again. You only have it in one place, and you keep inheriting it, and you don't have to write again and again and again. So that's code is more. And if you need to make a change in both of the classes, you just go into the account and make a change there. Both of those two classes. We'll do a lot of examples of this. Let's start with one thing you gotta make sure is you gotta understand which one is the parent, which one is the child. So you gotta draw out the hierarchy. So anything that's up on top is the parent, and this is the child. Account is a child of object. Now saving is an child account. So what's the relationship between saving and object? So object is a grandparent of a saving. And what's the relationship between checking and account? Child and parent. So what's the relationship between checking and saving? So it's sibling relationship, but they're not connected. That means they whatever you add in savings will not be inherited by checking. They have their own unique traits, right? So but they're coming from the parent class. If you make changes in parent, yes, then these two will be. But if you make a change in saving, count is not affected at all. So this is basically just an overview of how inheritance works. Let's do coding example, and you'll see how it actually is written. So I'm going to take this out. So now inheritance, let's do a dog class. So it's a very simple. Account might be a little complicated. So a dog class, if you need to draw it out, and that would be dog, and there'll be, we can have multiple ones, but two, and let's say it's a dog, right? Dog object. What's one of the type of dog? So we had account, then we have saving in, yeah, the breed. What's one of the breeds? Poodle. Yep. So poodle is one of them. Now, when you create this structure, this is how it's going to be. You're going to put all these functionality of both of these two dogs in the parent. They're coming from dog classes, but when we inherit them, all this functionality that we put in dog will be inherited into both. So what functionality can we put in the dog class? We can put a name as an attribute. We can say a function called bark. We can add that. There are a bunch more things we can add in there, but let's go and add these two for right now, and let's see how they're inherited into poodle and chihuahua. Write some override dog function to create an object. Remember, all those are object classes, right? So we have to create an object, add a Java class, and call that dog. So right click on source, add a Java class, just like you create an object for class. So I'm going to add a class called, and now if I go in, I can declare that class or object dog one, and we'll call that. Then nothing happens because we don't have any functionality. Everything exists in this class coming from where? Anything that exists right now in this class, where is it coming from? Object class, exactly. Remember, the object class is the most parent class for all of them. So it's coming, all the functionality is coming from object class. Remember, anything exists in object is no use to us because it's not the functionality that we want for our. So now let's go ahead and add those attributes. So I think we only said one. We'll come back and add one more later. String, let's set it to private. So I'm going to do string. So that's the field. And what else do we need to create an object? Constructor bark method, exactly. So let's do constructor first and then we'll add the bark method. Constructor would be name of the class. And in there, what we're going to do is we're going to ask the user to provide us with the name. So it'll be a user provided name. So the way we do that would be user name. And by using the constructor, we construct the object. So we initialize the field. So we do this dot name equals to, and whatever the user the field is initialized. Now we can add a method, and that method would be bark method. So it'll be, and all that method is going to do. Remember, this is just for practice, right? So just example. So what we're going to do is we're going to do system dot out dot print ln, and we're going to do, so when this bark method is called, all it's doing is printing woof. So I need to provide a name. What's a good name for a dog? So nothing happens because I actually haven't called anything. I declared an object, and that is it. So let's call that bark name, bark method. And the example is pretty simple. Create an object dog, calling it. So in this class, we can always add getters and setters. Let's go ahead and add it. So we do get method for name, so it'll be string. Get name, and all that's going to do is return this set method, void set name. The user will provide us the name parameter, and all we're doing is this dot name equals to bark method. I could also do dog one dot. Now get name method is not gonna print anything, so it's not gonna print anything. Why is get name not print, but bark is? Get name method right here is only returning the name, but the bark is actually have a system dot out dot print ln. And here, if we need to print out the name, I need to put that in system out. So run it again. Max is going with, and I'm going to switch the order so it prints the name first. So let's go ahead and add another object, and this one we're going to call it what? I'm going to go up and find the name. We should call it poodle. So it was poodle, a type of a dog or a breed, one of the breeds. And now the poodle doesn't have anything, right? And dog does. If you call an instance of poodle, dog two, new poodle, we do something like this. So now none of these functions exist in there, right? So I come in here, I do dog two, get name or bark. Obviously, none of those exist. If you look at the poodle, there's nothing in there. That's why I'm getting red lines and red syntax, because I'm trying to access something that does not exist. None of this exists in poodle. They only exist in dog object. So far, so good. All right, so now if you come to poodle and extend is the keyword that's reserved by Java. So as soon as you do that, now we have a parent and child relationship between dog and the poodle. The reason it's complaining right now, you need a constructor. You need to have a constructor. As soon as you do inheritance, you don't need to import any of the other stuff, right? But you do need to have its own constructor. So you can have a poodle. I'm going to keep the same string username. And inside this constructor, what I'm going to do is I'm going to call the super constructor. So what super constructor does is it goes in So let me create the hierarchy again. All right, so now this is dog. So now the super goes up in the hierarchy and tries to find something in the parent. So super, that's what it exactly means. That means so there were keyword we were using last 2 weeks, which was this, right? So this keyword means something that exists inside this class. So if we were using this keyword, that means try to find it in this class. Whenever you have a super keyword, that means go up in the hierarchy. Go up means whoever your parent is, go up and try to find a constructor that does the exact same thing. And I'm passing the parameter here, and I'm using dog's constructor in Poodle. All it's doing is getting the parameter and passing it to super. So now I come in here, I don't have those errors anymore. These two are gone because everything in Poodle is inherited from dog. So these methods exist in Poodle as well. The only thing it's complaining is about the constructor, because I don't have a default constructor here. So now it's asking me to pass something in. So what's another name for dog? So now we have Lola, and now we have a poodle named Lola. Now it's coming from everything inside here is coming from dog. We are allowed to use any of the functionality that exists in the dog, even though we're working with, we get Max goes woof and Lola goes woof. So every time you're doing inheritance, remember, as soon as you do extends keyword, that's when the inheritance starts. So you have extends dog, and now the parent is the dog and the child is, remember, you have question or concerns, please raise them as soon as you think of a question, otherwise you'll stay behind and you'll be confused the whole time. So make sure you ask questions in class. Office hours, that's fine too, but you ask questions, that's the main thing. I did post tutors of office hours and their links, how to join them and how to look up the hours. So if you are not able to make it during my office hours, they're open. They'll be able to help you. The students, they have taken these classes, I think, except for one who hasn't taken it. But I think she was only able to help you with Python. But the other two are able to help you with this. They have taken these classes, and if you're confused about any of the topics, they'll be able to explain it. So we have poodle, we have dog. So now let's go to override one of the functions. Let's say we have a bark function in here, but we don't like that bark function. We want to change it because the poodle might sound different than any of the other dogs. Let's say we want to keep this for default. So I'm going to copy this. All you do is create a new bark function in Poodle, and whatever you do in here will be overwritten this bark function. Now, so if I run it, remember this dog object, that's not overwritten, right? So this would stay the same. This bark function would stay the same, but Poodle function, bark function will now be woof woof. So Max is going woof, and Lola is going woof woof 2 times. So let's go ahead and add the third one. So we're going to add the third one, and the third one is going to be, what did we call it? Let's scroll up, and we call it Chihuahua. We're going to copy and paste the name. Go ahead, enter, and now same thing, just like Poodle. If I create the third dog, dog 3 equals to new, and that is what's the name? Well, you guys are coming up with the name. So now I don't have a constructor in there, right? So Chihuahua doesn't have a constructor. It doesn't have any of the functionality. Why does it not have any of the functionality? So if I do something like this, if I use these method dog 3, why am I not getting something? So you need to extend the class of the dog, exactly. So right now, remember the only reason Poodle has all the functionality because we did extends dog. The Chihuahua doesn't have anything yet. So now we do extends splitting. You need a constructor to match the super. I think you have an option to just do it from here. So imports exactly what I did for Poodle. So now it's complaining I didn't leave, no name. So give it like a tiger or something. So run it. So Max goes woof. Lola is woof woof 2 times, but tiger is basic. It's coming. Everything is coming from dog class. So now everything will be just default. So we can set. So what you can do is when you create a class like dog, You can set all the default values here, but if any of the child classes need to override them, they can just take about 3 to 4 minutes, add one more class to this. So we added poodle, we added chihuahua, take 3 to 4 minutes, add another child class. So add a third one, a third breed of a dog, modify the bark function as well. Take 3 to 4 minutes. What's another name breed for dog? Someone else is adding? What are you guys adding? Pug, Labrador, yep. You need help. Yorkshire, I think is one of them. Golden Retriever, Husky, yep. German Shepherd, yep. So go ahead and add one more class with that name and add this functionality, at least this. You can add more if you wanted to, but you can add this. So you type in yes or thumbs up. As soon as you get add another breed and add those functionality, just type in yes, done. Could you go to the dog class? So I can type in and show you all the examples that in the world, but unless you do them yourself, you're not gonna learn. That's how it worked for me, and I've seen that over time with students. Unless they actually type the code and practice, they don't actually learn. That's why I'm forcing you to do it. Create another class just like this, so you get an idea of how inheritance is actually working. So I'm gonna add another class called Husky, and Husky, I'm gonna do extends. The dog, it's a create constructor from the super. I'm gonna just do it add import. Constructor is created, and let's go ahead and add that here. So then I have Chihuahua, and I'm gonna add the third or fourth dog. And now, what's another name for dog? Lola, Max, Tiger, and what else? Lion. So now, the only method that's being overwritten right now is in Poodle. That's Lola, that's going woof woof 2 times. Let's go and add that overwritten method in Husky as well. So I'm going to copy the bark method, and I'm going to add that in there. And Husky is actually going woof woof 3 times. And now if I go back and run it, so you're not actually limited to everything that's only in the parent class, right? So you can have your own traits. So all the child, they can have their own functions. You can add more functionality. Let's say there's a function, what function can we add? So let's do bite function, right? So bite function does not exist in the parent class, but we can go ahead and add it in the child class. That is not going to be affected anywhere else. So let's, for Husky, we're adding it a bite function, and all we're going to do is system.out.println, and we're going to do Husky is bite. So now if I go to the main class, if I try to call that function for dog, so do dog1 dot bite, the bite function does not exist. So this actually does not exist here. If I take this and call that for one of the siblings, which is poodle, so that would be dog2. That still does not exist here. Remember, when you add functionality, any of the child classes, none of the parent classes are that only exist in the child. So I'm going to take this out and add it where it should go, which is the Husky, and this is going to be 4. And now I get this for Husky. Name is going woof woof woof, and it's going Husky is biting. Child parent relationship. Hopefully it's making sense. Let's go to create another child and parent classes. Delete this to create. Let's say we have an employee class, and we'll do 3 child classes. From this parent, we'll have 3 child classes, and we're going to name it employee. So you have an employee, right? So any company that you go to, you have an employee, and then you have different types of employees. So the class structure would be look something like this. So let's say it's a lawyer's office, so that would be a lawyer like this, and this would be, let's say, secretary. So all these are employees of a company, but they're different rankings, right? So you divide that up and different types of employees. So what could go in employee? What can we add in employee? What's the functionality can we add? So any employee in a company, let's say name, yep, we can add a name. And then we can add hours they're supposed to be working, right? Fields. So hours, they could have a salary, how many vacation days they're getting. Let's do vacation form. Vacation form, let's say if they have to fill out the form for get the vacation, request for vacation hours, the form, what kind of form is it? What color is it? So all this could go in employee and all that functionality will be inherited in all of them. So let's go and create something like this. So I'm going to leave that up and go and create it in IntelliJ. So we'll do Java class and we're going to be calling it employee. And employee, I'm going to add all that functionality in and we're going to add string name. And the next is double hour, double salary, then int vacation days, spring vacation. This vacation form would be like a vacation form color. What type of form would the constructor would be? Let's see, employee, and what things we're going to be asking the user, right? So in this case, let's do the name, I guess. Yeah, that's name is the only thing we're going to be asking. Username. It's trying to make something a little different. So let's I'm gonna get rid of the name, sorry. Keep something that they maybe don't even have to provide. And we can set the default constructor. So we'll do employee hours equals to 40. So you're gonna be working 40 hours. The base salary we can set to 50,000. Vacation days, everybody gets 10 vacation days per year. And vacation form for default would be, so now I'm gonna go to main and I'm working with employee object now. Let's create employee v1 equals 2 and call it new. And I can print any of the things out. I can do employee one dot. Since I didn't set it to private, I said right now I have it to public. I can access the fields right away. So if I run this, just want to make sure it's working before we move on. Let's create the child classes. Now we do lawyer, and the last one is, and now these three are child classes. All I'm going to do is extend. Same with this one. I'm going to do janitor extends. All these are coming from employee. So lawyer extends. So each of the child classes extended employee for all three of them, and there's nothing actually in them. Everything is coming from here. So if I go to the main, I can create lawyer employee 2 equals 2 new employee dot out dot println. I get 40. I get 42 times. So we did child relationship. We did so now. So what I'll introduce you to it, but I think we'll work on it on Wednesday. So one thing you can do right now, remember there's object and then employee, then lawyer, and all these child classes. You can have classes below child classes as well, and they're also known as parent and child relationship, right? So let's say for this example, you have secretary, and you can have let's say different types of secretaries. So you can have legal secretary, and you can have, I just said, another secretary, different type. So now, legal secretary is a child of secretary. So this is a parent and child relationship. So legal secretary relationship with the employee is grandparent and child. So anything that exists in the hierarchy above legal secretary exists in legal secretary. Anything, so all these extended obviously. And now when you declare legal secretary, let's actually do that, create a class. And we're gonna call that legal. Yeah, so that's what I want to show you guys. So you have legal secretary. So now you don't want to do extends employee now. Remember, you want to extend whoever you want the parent to be. In this case, we want the parent to be secretary, and that's what we're gonna do. So now, as soon as you do that, this is how the class structure becomes. So now this is the child, this is the parent, and this is the grandparent of legal secretary, and employee is the parent of secretary. And all four classes have